All right. So let's do this question here, right? What is the speed of the marble when it has risen only 15 centimeters? We know, by the way, that it goes 18.3 centimeters high. So we literally are going to say, well, okay, when it's partway up, when it's almost at its highest point, how fast is it going? So that's 0.15 meters, right? And then this distance here, yeah, anyway, I'm trying to think about that. It's by the way, it's just barely above the spring, right? Because we compress the spring 12 centimeters, right? So it's only 3 centimeters above the spring, but let's not worry about that. Our drawing maybe isn't to scale here, okay? So here we have just potential energy, so just the 1/2 kx squared, because it's at the lowest point, it's not moving, there's no force other than the spring that pushes on it, right? And then when it's partway up, it's got mgh, and it's got 1/2 mv squared. That is, it's still moving, and it's also not at its highest point, and it's also not at its maximum velocity. It's got a little of both. Okay. I think we can plug in, right? So 1/2, what's our k? K is 35. What is our x? 12 centimeters, so 0.12 meters is equal to, what's our mass? 140 grams. So 140 grams is 0.14 kilograms, which is what we want to use. How high is it? It's 15 centimeters, right? So 0.15 meters plus 1/2, still 0.14. And I guess V is what we don't know. There it is. All right. So I'm going to do this side here. So 0.5 times 35 times 0.12 squared is a whopping 0.252 joules of energy. This is 0.14 less than that, I assure you. Times 9.81 times 0.5. It's got to be less, right? This is 0.20601 plus 1/2 0.14 v squared. So I'm going to go this minus this. That guy minus this guy. There's a whopping 0.04599 equals 1/2 0.14 v squared. And now we're set. We're going to take this, multiply by 2, divide by 0.14, and I get 0.657 is v squared. So if I square root that, I get V is 0.810555, and then it just keeps going meters per second. So with 3 sig figs, I'd say V is 0.811 meters per second. Woohoo!